Okay, take your attendance. Okay, class. So let's start. We'll be starting a new topic today. Topic 8, capacitance. Okay. Okay. So we go to the slide. You can get the notes as usual. You can get the notes from this under 8 to notes. Go to 8, capacitance and capacitance. We'll be discussing this today. Okay. So let's go to the slide. Okay, class. So can you hear me, right? Anybody? Can you hear me?
Yeah.
Okay, thanks. Okay. So this is 8 topics, something related to electric field too. Capacitance. I believe you heard about capacitor before. Okay. So these are the 3 subtopics we're going to talk about now. Okay. So capacitor, capacitors, the image like this. I think it's one of the very important component in electronic is capacitor. You let's say you dismantle your laptop or you dismantle your TV, the electronic device at the board, the motherboard. You can see some shape like this, like a cylindrical shape. It's actually capacitor. Okay, you have a big size and you have a smaller one. I believe you done one experiment last semester, right? Charging and discharging capacitor. Yeah. So this is the symbol for capacitor. Okay. The symbol of capacitor, the both plates are same equal length. Same like battery. Battery, one is longer, one is shorter. One is positive terminal, another one is negative terminal. But capacitor is both terminals same length. Means the capacitor also act like a battery. Once it store charge, it store energy, it tend to become like a energy source. Okay, it's like a battery. But any terminal can become positive. Okay, maybe left become positive, right also can become positive. Depend which direction you charge it. Okay, so in this circuit, you see the shape like this capacitor got. In this circuit, got lots of capacitor 1, 2, 3, 4, like 4 capacitors in this circuit. This is a transistor. Okay. Okay. So what is a capacitor? So what is the function of capacitor? The capacitor is a device that can store charge or energy. More to say, more logical, store energy. Okay, a capacitor is a device that can store storing energy. It consists of 2 plates separated by a insulator. So it's like a 2 parallel plate. In between, you can have insulator. Okay, you can have insulator. You can have air. You can have oil. But in your syllabus, it's vacuum. Okay, the center is vacuum. Okay. So how a capacitor works? Okay, this is the diagram explains. This is the capacitor. Inside the capacitor is like a parallel plate actually. Parallel plate. Okay. So the capacitor will connect to the bottom to the battery. So the charge will flow to the capacitor and store the charge. To be more depth, we go to the next slide. Okay. You can see here. Okay. Look at the first diagram. So when you connect the switch, okay, when you connect the switch, charging happen. Okay. The electron move from the negative terminal. The electron move from negative terminal. Okay, this is where the electron moves, negative terminal, it accumulate at the left plate. The electron accumulate at the left plate. The electron move from the negative terminal of a cell to one plate of the capacitor, and from the other plate to the positive terminal of the cell. Okay, see, the electron will move from negative terminal, accumulate to one of the plate. Okay, the electron cannot cross over, the electron won't cross over because more electron accumulate in the left plate. Due to force, the electron which is on the right plate will be pushed to the right, forced to push to the right. So the electron on the right will flow back to the battery, Okay, this causes the left plate become negatively charged because accumulation of electron. The right plate become positively charged because electron leaves the plate. Okay, yeah. So that's charging. The electron move from negative terminal to the left plate. Due to repulsive force, the electron from the right plate will be pushed backward to the battery. Okay. So now this process continues. The release of electron and accumulation of electron on the left plate continues until right? This is like a parallel plate. The capacitor is like a parallel plate. Okay. So when this is negative, when this is positive, okay, when this is positive, this is negative. Let me go to the whiteboard, more clearer. Okay, you have the capacitor. This is your capacitor. The capacitor connected to a battery. Okay, so when the electron moves this direction, okay, this become negatively charged. This become positively charged. Okay, because here there is a negative and positive charge, there will be a voltage. A voltage developed capacitor because accumulation. Okay, this capacitor create a voltage like a battery which has a voltage like capacitor, because this the right side is positively charged, right? So the right side will be like this direction to become like a battery. Okay, you see the battery at the bottom, the driving cell has a 6 volt capacitor charge. The charge, the voltage accumulate, the voltage might rise to 2 volt. Okay, when more charge accumulate, the voltage rise to 3 volt until 6 volt, rise up to 6 volt. Okay, when the voltage rise up to 6 volt, when the capacitor voltage rise up to 6 volt, what happened? Like the capacitor battery and the bottom is another battery. This is 6 volt. This is so use Kirchhoff's second law. Because Kirchhoff's second law. What is the sum of EMF in this circuit will be? Positive terminal connected to positive terminal. What is the sum of EMF will become 0 volt, right? So what happens? Yeah, sorry, I think slightly disconnected. Okay, the current will stop flowing. Okay, when the capacitor reach 6 volt. the same voltage as the battery, the charge will stop flowing because no total EMF becomes 0 volt. So no EMF to drive the current. So current stop flowing. So capacitor stop charging. Okay. So capacitor stop charging. So that's the idea of the second diagram. You see the second picture. When fully charged, the voltage of the capacitor will be same as the EMF of the cell. Okay, EMF of the cell. No current flow in the circuit after fully charged. I think you realize this when you do the experiment in the last semester, right? When you close the capacitor, close the switch, charging it, you can see that you place the emitter reading will go down and down, finally become 0 when completely charged. The voltage across the capacitor become constant, same as the battery, right? I hope you remember. Okay, so when fully charged, the capacitor will have the same voltage as the battery. Okay. Okay, now, so this is charging and process of fully charged. Okay. Once the capacitor is fully charged, we can connect the other side. We can move the switch from the left, from the bottom. We leave it. We connect it to the other side. The other side, let's say here you have a light bulb. Let's say you have a light bulb here. You have a light bulb. Okay, now the capacitor can release the charge to the light bulb to light up the light bulb. Okay, to light up the light bulb. So the current will flow this way now. The current will flow this way to light up the light bulb. Okay. Normally, you know, your camera flash, no, the flash, sudden brightness produced by the light bulb. The flash was actually connected to a capacitor, a charged capacitor. Okay. When you press the button, the camera button to have a flash, the entire charge of the capacitor will be released to the light flash to create a sudden bright light to be produced. Okay, so one of the uses of capacitor. Okay, any questions so far? Charging, fully charged means the voltage of the capacitor will be same as the voltage of the battery. When do discharging, the current in the capacitor will flow in opposite direction. Okay, so charging, when you connect the battery, the charging, the current flow this direction. Okay, you look at the first diagram. The current flow, let's say you focus your capacitor, the current flow from B to A when charging. Okay, when discharging, the third diagram here, the current flow from A to B. Current will flow from A to B. Current will flow in opposite direction during discharge. Okay. Let's continue.
Sir, I got a question. I thought the electrons can't flow through the insulator.
Yep.
The electron can flow through the insulator like during discharge?
No, it can't. It can't flow through the insulator. The electron cannot bypass the insulator. Cannot bypass the insulator.
Okay.
So, for example, I go to the next diagram. You see here. Okay, this diagram is better. So, when you're charging, according to this diagram, when you're charging, the negative will flow and accumulate here. Let's say this negative charge cannot bypass this insulator. Because of the repulsive force, the electron which is in the left plate will be pushed to the left. Okay, so at the end the left plate become positively charged. Okay, no electron crosses the insulator. When discharging, the electron from this plate, from the right plate, will leave the plate, go to the next circuit. The circuit is on top, which connected to the light bulb maybe. Then the electron will reach the positive plate. Neutralization happen. So no charge transformation happen in the insulator.
Okay.
Shakil, got idea?
Yep, I got it.
Got it. Okay, good. Okay, look at this description. When this charging discharging, when the capacitor is charging, electron flows from the battery negative terminal to a plate A. In this case, the plate A, and then from the other plate B to the positive terminal. Okay. So yeah, you know, right? Before charging, the plate A and plate B is neutral, right? It's neutral. That means what is meant by neutral? Neutral means they have same amount of positive and negative charge. Okay. Let's say on the A you have 50 electron. You have, let's say you have a 50 proton. 50 proton. So it's neutral. A is neutral. B also, let's say you have 50 electron, 50 proton. Let's say before it was charged. When charged, the electron will start to accumulate on the A plate. That means the 50E, right, will start to rise to maybe 70E or 80E. Let's say it's become 80E. Okay. Okay. So now the 50E on the left side electron will start to push backwards. Okay. So the 50E on the left will drop to maybe 30E. Slowly it leaves the plate, go to the battery. Okay. So this process continues until left plate got lots of negative charge, and on the right plate, on the left plate, you don't have any negative charge. All has been pushed downwards. This process continues until the voltage of the capacitor become same as the voltage of the battery. Okay. Okay, so equal amount of positive and negative charge then accumulated at B and A. Yeah, correct. B and A. We can say it like, for example, we can say if this is negative 50 column, here you will have a positive 50 column of charge. If you accumulate negative 50 column of charge here, negative 50 column of charge from left will leave. Therefore, the left plate tend to become positive 50. Okay. So positive 50, negative 50. Okay. So equal amount of positive and negative charge then accumulate B and A. Okay. Results in the existence of PD across the plates. Okay. This PD is counteractive to the EMF of the battery. Counteractive means it opposes the EMF of the battery. Okay, I can say it's against the creator. The battery helps to store the charge, but the voltage created by the capacitor opposes the voltage of the battery. Okay, this causes the current in the circuit to become dropped. At the end, the current becomes zero. Okay. So the result is an existence of PD buoy across the plate. This PD counteractive to the EMF of the battery. Okay. Okay. Yeah. When V reaches V0, the V0 is the voltage of the battery. No current flows through the circuit. There is no accumulation of Q amount of charge in the capacitor. So capacitor consider completely charged. Okay. During discharging process where the battery is disconnected, the reverse flow of electron occurs across the capacitor. Okay.
So why is there no current flowing again?
Why no current flowing? Because as I said, like whiteboard just now, I told you. Look at this diagram. Like I told you, the capacitor is tend to become like a battery, right? Like a battery. Okay. So the voltage of the capacitor increasing. So finally, when the this is capacitor, let's say the capacitor is actually like a battery, store charge and store energy. So when the capacitor voltage increase to 6 volt, so the battery also 6 volt. The positive terminal of the battery is connected to the positive terminal of the capacitor. 6 volt. What is the total EMF? You remember Kirchhoff's second law? You take the clockwise direction, let's say clockwise direction. The total EMF will be 6 minus 6, right? So the total EMF becomes 0 volt. So when the EMF in the circuit becomes 0 volt, the total EMF becomes 0 volt. There is no current to flow. For the current to flow, you need to have potential difference. Okay. The bottom battery wants the current to flow in an anti-clockwise direction. But the capacitor, which also 6 volt, want the current to flow clockwise direction. So opposing each other, finally no current flow because total EMF is 0. Okay. Tejuan, right? Got the idea?
Yeah. Yeah, I can understand.
Okay. Okay. So let's see. Continue. Okay. So when charging, this is what the graph looks like. When the capacitor was charged, okay, charge means, as I told you, the first diagram connected to the battery. When the capacitor charged, the current flow definitely going to decrease. Definitely going to decrease. It found to be decreases exponentially. Okay, it decreases exponentially. The current will decrease exponentially. Okay, exponentially. When discharging also, current will drop exponentially. Okay, we will be discussing this later. Okay, so remember when the capacitor was charged, the current will drop in the circuit exponentially. Okay, when 6 volt, current finally become 0. Okay, when discharging means when the capacitor connected to another circuit with a light bulb, let's say, okay, the current will release from the capacitor to the light bulb. When the charge is released from the light bulb, the voltage across the capacitor will start to drop. Voltage across the capacitor will start to drop when charge start to release. So again, the current will decreases exponentially when discharging. Okay, but why it's in a negative region? Because the current flow in opposite direction. Okay, when capacitor charging, as I told you in this diagram, A, B. When charging, current flow from A to B. When discharging, current flow from B to A. Okay, that's why the direction of the current is negative when discharging. Okay, but finally, charging or discharging, finally the current will drop to 0. Okay, we will be doing this towards the end about the graphs, the discharging current. Okay, this second graph, I'll come back to you after I discuss the next slide. Okay. Okay. So why capacitor? Learning capacitor is so important. What is the use of capacitor? So there are lots of important uses of capacitor. You can say these are the 3 main uses. Okay. The first use of the capacitor is to store charge for high-speed use, such as camera flash, as I told you. Camera flash, suddenly you want a big charge to flow to the flash to have a maximum brightness. You need to use a capacitor. Okay, capacitor, because current of the capacitor will release with a high current drop to 0. So first, capacitor needed for a camera flash. Okay, that's one uses. Second uses, I believe you will come across with this, right? Smoothen out DC voltage that has ripples. Do you learn about DC voltage that has ripples? Okay, what is DC voltage as ripples? Let me clear this. TNB gives us alternating current, right? It supplies alternating current. Okay, when alternating current get into your home, okay, get into your home. Let's say you want to use your laptop. Okay, your laptop uses direct current. Laptop uses DC. Okay, but TNB gives us AC, alternating current. Okay, so when alternating current get into your laptop, you have an adapter. Inside the adapter, you need to change this AC to DC. Okay, you need to convert AC to DC. Okay, so the alternating current will be converted to direct current like this. This is a direct current. Okay. This is alternating current. On the left is alternating current. This is AC current. Will tend to become direct current. This is your DC. Anybody? Do you learn the transformation of AC to DC in your O levels? What device do you use to convert AC to DC? What device? Anybody?
A transformer?
Okay, transformer. Transformer is used for what? Transformer is used to alter the voltage, to change the voltage. From 240 volt, you want to drop to 8 volt, transformer does the job. Okay, but transformer, the 240 volt alternating current, the 8 volt also will be alternating current. It won't change to DC. So what component change AC to DC? Diode. Okay, we use a diode. A diode will convert alternating current to direct current. Okay, so diode always allow the current to flow in one direction, right? Okay, so this is a positive current, this is a negative current. So positive current when pass by, the diode allow the current, but when it comes to negative, okay, it will block the current from flowing. Okay, if I want you to draw another one, okay, let's say this is full wave one. So let me make it easier. So let me rub this. Sorry. When go the half wave, half current, the diode will allow the current to flow. When the current negative, when the current flow in opposite direction is negative, the diode will block it, so you won't get any current. Then you'll have a current again. Okay, so the diode turns the AC to DC, direct current. Okay, but this direct current it has a ripple. This is called ripple. This is called ripple. Ripple means the current from 0 go to the maximum, go to 0 again. Like the current is not constant. Okay, current is not constant. Okay, but the best direct current we can have, the graph going to looks like what? The best direct current should be a straight line, right? The direct current have to be constant. This is the perfect direct current. From your dry cell, the dry cell you use, the current comes out from the dry cell is constant like this. The graph I draw just now, it's constant. Okay. So if the current has a ripple like this, current go 0 to maximum. So the laptop, let's say connected to this ripple current, what happened? Maybe the brightness of the screen maybe get dimmer and brighter because the current flow constantly changing as 0 to maximum. So what we need to do, this ripple we need to convert to like this, convert to like constant current. Okay, how we can do this? By using a capacitor. Okay, capacitor does the job. Okay, capacitor, what capacitor can do is, capacitor can discharge and store charge until this path can be connected. This path can be connected. Okay, so it create a current like this. It create a current like this. So finally, what happened? You get a current which is not dropping a lot to 0. It's just dropping a little, but it's better than the previous one, which is dropped to 0. Okay, so this called smoothing. Okay, this called smoothing. We will talk about this AC later. So for time being, what is the use of capacitor? Next use is to smoothing the ripple. Okay, smoothen out DC voltage that has ripples. Okay, so this is called ripples. This is called ripples. Smoothen out. Smoothen out means it will connect. Okay, connect until the current never drop to 0. Okay, so that's the second function of capacitor. The smoothing part we will talk in depth in the AC topic 11 later in A2. Okay, so for time being, understand capacitor used for the smoothing of DC voltage. Okay, third uses of capacitor is block DC voltage. Okay, blocking the DC voltage. No current will flow between the poles of the battery once the capacitor is charged. Okay, why you need to block the DC voltage? One example, why you need to block the DC voltage. Let's say let's say someone is talking in the big hall. Okay, they have a microphone. They hold a microphone. The microphone is connected to a amplifier. Okay, you have an amplifier. Okay, you have an amplifier. Okay, then the amplifier is connected to the speaker. Okay, connected to a speaker. Okay, so the microphone, right? The microphone. What is the function of microphone? Anybody? What is the function of microphone? Changing sound to electrical signal, right? Changing sound to electrical signal. Right? It produces an electrical signal. Okay, you see it hello. The microphone change the sound to electrical signal. The electrical signal is actually a current. The current will flow into the amplifier. Okay. The type of current produced by the microphone is an alternating current. The type of current flow from the microphone produced by you is an alternating current. Alternating current will flow to the amplifier, and the amplifier will amplify the signal and give a louder sound by using a speaker. Okay, but this amplifier was connected to a power supply. The amplifier is connected to its own power supply. Okay, direct current. It uses DC, direct current. So the amplifier current sometimes can leak into the microphone. Okay, can reach the microphone. Okay, can leak to the microphone. So if the direct current from the amplifier leak to the microphone, if you are holding the microphone, you can be electrocuted. Okay, so in this case, we want the alternating current from the microphone to reach the amplifier, but at the same time, we don't want the direct current from amplifier to reach the microphone. So how do we do that? So we place a capacitor between the microphone and the amplifier. A capacitor will allow the alternating current to pass by, but block the direct current from flowing. It block the direct current from flowing. Correct, right? You see, if you have a battery, okay, if you have a light bulb, okay, you put a capacitor in series. You put a capacitor in series with the battery. Okay, so you switch on the battery. Okay, switch on the battery. The light bulb will light up maybe few milliseconds until the capacitor become charged. If the battery is 6 volt, the capacitor will be charged with 6 volt. Once the capacitor charged with 6 volt, current becomes 0. So the light bulb won't light up. So indirectly what we can say, the capacitor blocks what? Blocks direct current. Capacitor blocks direct current by charging itself. It charge itself, it create voltage, it blocks the direct current. Okay. But if the capacitor connected to alternating current, okay, if you connected to alternating current, okay, let me go to the whiteboard. Quite messy. Okay, let's say this is the symbol of alternating current, right? Let's say you put a capacitor and you have a light bulb now. You have a light bulb now. Alternating current, AC. Okay. This case, the current will flow this way. Let's say the current will flow this way for the first half cycle. Let's say this is going to be positively charged. This will be negatively charged. The light bulb will light up. Okay. After capacitor about to charge, the alternating current will change the direction of the current flow. The current flow will flow in opposite direction, right? Every half cycle, the AC current flow in opposite direction, right? Now the current flow in opposite direction. So what happened to the capacitor? Capacitor which was earlier charged, now will be discharged. So the light bulb still will light up. Because current continuously flowing. Okay, current flowing to the left or right, the direction of the current is changing, but the current is continuously flowing. Therefore, the light bulb will light up. So conclusion is capacitor unable to stop AC from flowing. Okay. So capacitor blocks DC, but capacitor allows AC. Okay, it allows AC. So this causes it to have the third uses. Okay, the third use is what? Block DC voltage. When do we need to block DC voltage? The one situation I told you, microphone. Okay. Okay, any questions so far? Anybody? Okay, no questions, huh? Okay. So let's continue. Okay, now we slowly get into the calculation part. Okay. So capacitor is actually made of two parallel plates. It's actually made of two parallel plates. In between got vacuum. Okay, sometimes got insulator. Okay. So the quantity of charge accumulated on the plates is directly proportional to the voltage. This is what discovered. Okay. You want to store more charge on the plate? It depends to the voltage you apply. The voltage you apply. Okay. You apply 3 volt, the charge stored maybe 3 coulomb. You increase the voltage to 6 volt, the charge accumulated in the plate will increase. Okay. So the amount of charge stored on the plate in each plate is directly proportional to the voltage between the plate. Okay. So now they found that for a specific capacitor, the QOV is found to be constant. Okay. The charge per unit volt is found to be constant for a specific capacitor. Okay. So this QOV, which is constant, they name the constant as capacitance. Okay. The ratio of charge over voltage, they label it as capacitance. Okay. Capacitance is the title of the topic, capacitance. Okay. So if the capacitor can store more charge per unit volt, we can say it has a greater capacitance. Let's say for example, let's say you have a capacitor. Okay, you apply a battery, you give 1 volt, you store 5 coulomb of charge. Okay, you store 5 coulomb of charge. Okay, you have another capacitor, you apply 1 volt, the capacitor store 10 coulomb of charge. That means we can say this is the capacitor B, capacitor A. We can say the capacitance of B is greater than capacitance of A. Okay, so what is capacitance? The amount of charge stored, okay, in each plate to the voltage or potential difference between the plate. It's called capacitance. Okay. Okay, let's go in depth about it. The capacitor is a measure of charge storing ability actually. If you have a capacitor with a greater capacitance, means it can store lots of charge per unit volt for every volt. The capacitance symbol we use C is defined as, this is the definition. So remember, common definition. What defines capacitance? What is capacitance? It's the ratio of charge stored on either plate to the potential difference between the plate. It's called capacitance. Okay, this is the formula. C equals to QOV. Don't say capacitance is the ratio of charge stored per unit volt. Okay, don't say that. You say capacitance is the ratio of charge stored in each plate. You must say the charge stored in each plate to the potential difference between the plate. Don't forget to say between the plate. Is capacitance. Okay. The capacitance as you can see it's a weird unit. Okay, the unit for capacitance, of course, you see charge volt, right, is coulomb per volt, right? Coulomb per volt, right? Charge is coulomb, volt is volt per volt, coulomb per volt. But as a special name called farad. Okay, the unit for capacitance is farad. Okay, so if it has 1 farad means what you should understand, it can capable to store 1 coulomb of charge per volt. Yeah. If you have a capacitor stated as 1 farad means you should understand you can store 1 coulomb of charge for every 1 volt you apply to the capacitor. If you apply 10 volt, you can store 10 coulomb, can store 10 coulomb, and so on. So that's meant by 1 farad. Okay. Okay. So usually 1 farad is a very big unit. 1 farad is a huge capacitor. Okay. You know what is the largest capacitor in the world? The largest capacitor. The largest capacitor in the world is our Earth. Earth itself. The Earth is the largest capacitor. Okay, because Earth has capability to store charge. Okay, Earth. So Earth has its own capacitance. It has its own capacitance. Okay, you check from Google. Even Earth, which is the largest capacitor, the capacitance of Earth not even 1 farad. I think few microfarad if I'm not mistaken. Okay, so the unit 1 farad is very huge. So the normally commercial capacitors we have in your electronic boards, normally they will have smaller units like microfarad or picofarad. Okay, microfarad or picofarad. So I believe in your second term, the second semester experiment, when you do, have you checked what is the capacitance of the capacitor you used? Is it 2000 microfarad or something? Can't remember. So the unit for capacitance normally we use will be in form of microfarad or picofarad. Never farad, because farad is a very big unit normally. Okay, if they say the television is fixed with a capacitor of 1 farad, cannot be. 1 farad is lots of capacitance. Normally will be like 10,000 microfarad maybe. Yeah. Okay, so from this slide, you should understand the definition of capacitance. You should understand the unit is farad, and you should understand the farad. 1 farad is a very big unit. Normally we use microfarad, picofarad. Any questions from this slide? Anybody? Okay. Okay, let's we continue. Okay, so let's we go one example. Okay, look at this question. Okay, so there is one circuit here. A 12-volt battery was connected to a microammeter. It was connected to a resistor of 1 mega ohm, and in series connected to a capacitor which has 22 microfarad. Okay. Okay, the diagram shows a capacitor connected in series with a resistor. Okay, they are just explaining the circuit. So we straight go to the question. A, when the switch is first closed, what is the PD across the capacitor when the switch is closed for the first time, when the time is 0, just closed. Okay, when just closed, what is the voltage across the capacitor? VC, I put VC, V at capacitor. What is the voltage across the capacitor will be? What is the PD voltage? PD voltage across the resistor will be when the switch is just closed. First, can anyone tell me what is the PD across the capacitor will be? It was not charged yet. It was not charged. Just close the switch. Because the capacitor don't have charge. Okay. So C equals to Q over V, right? C equals to Q over V. Okay. So because you don't have charge, so the capacitor don't have voltage, right? So before charging, the VC must be 0 volt. There is no voltage across capacitor. Okay, yet, because not yet charged. Okay, when it accumulates charge, the voltage across capacitor rises. So the first answer, A1, when the switch is closed, what is the PD across capacitor? 0 volt. What is the PD across the resistor will be? What is the PD across the resistor will be? I think you can use Kirchhoff law. You see the 12 volt. 12 volt should be shared by the resistance. Should be the resistance, right? The resistance and the capacitor actually, the capacitor. Okay. So because capacitor don't accumulate any voltage yet, okay, it doesn't accumulate any voltage. So the resistor will use 12 volt. The resistor will take all the 12 volt. Okay, the resistor will take all the 12 volt because capacitor voltage is 0. Okay, so that's the first answer, A1. The PD across capacitor is 0 volt, PD across the resistor is 12 volt. Okay, what is the current? What is the current flow in the circuit when the time is 0? How much is the current flow in the circuit when the time is 0? So how you can find the current? You can use the information of the resistor to find the current. Okay, the resistor is 1 mega ohm. The resistor used 12 volt. So then you can work out what is the current flow through the resistor, right? The current flow through the resistor is the current flow across the circuit, right? So what is the current flow across the resistor? What formula comes to your mind? I equals to P over R, correct? P equals IR. So the voltage across the resistor is 12 volt. The resistance of the resistor is 1 mega ohm. That means 1 times mega. Mega is what? 1 times 10 to the power of 6, right? 6. 12 divided by 1 times 10 to the power of 6 is the current flow in the circuit. And time 0. Okay. The highest current. The highest current will be at the beginning. Okay. So V over R can be used to find the current. Okay. Okay, now part 4. What is the charge on each capacitor plates? When the time 0, there is no charge stored yet in the capacitor, in the plates. So the charge stored in each plate, of course, is 0 coulomb. Haven't stored charge yet. Okay, just connected. Okay, that would be the A answer. When switch is just closed, the PD across the capacitor 0, the PD across the resistor will be exactly same as the PD of the battery. All the voltage used up by the resistor, 12 volt. So the current will be maximum. Current can be obtained by using V equals to IR. The voltage across the resistor and the resistance of the resistor can be used to find the current flow at that moment. And of course, charge stored in each plate is 0 for the capacitor. That's the beginning. Okay, now look at part B. Calculate the same quantity as in A when the switch has been closed for some time so that steady conditions have been reached. That means what trying to say, the switch is closed until the capacitor is completely charged. Steady condition means the capacitor, after capacitor is completely charged. How these 4 quantities will be? When capacitor is completely charged, what is the B1? The same question. The PD across capacitor will be. What will be the PD across the capacitor? When the capacitor is completely charged, the capacitor will take the same voltage as the battery, right? So the voltage across the capacitor will be 12 volt. Voltage of the capacitor slowly rise to the voltage of the battery. So it reached 12 volt. What is the voltage across the resistance will be? So capacitor 12 volt, battery 12 volt. So the total EMF of the circuit becomes 0. So no current flowing, no current will flow. When the capacitor completely charged, current flow becomes 0. So the resistance won't take any voltage, right? Resistance only will take voltage when there is current flow through it, right? When the capacitor is 12 volt, the total EMF of the circuit becomes 0, current flow drop to 0. So what is voltage across resistor? Will be 0 volt, right? It will be 0 volt, correct? 0 volt. So third, what happened to the current? What is the current flow after the capacitor completely charged? Of course, current turned to become 0. No current flows after capacitor completely charged because total EMF of the circuit become 0. Then fourth, what is the charge on each capacitor at this moment? When the capacitor is completely charged, what is the charge stored in each plate? This you have to use this capacitance formula. So capacitance is Q over V. So find the charge stored, CV. Yeah, the capacitance of the capacitor multiplied by the voltage across the capacitor, which is in this case 12 volt. 12 volt times the capacitance, how much? Capacitance is 22 microfarad. So we put here 22 times 10 to the power of -6. So we get the charge in Coulomb. So finally, you should get these answers. Okay, so try to understand how the voltage varies for capacitor and resistor. Okay, when start the switch, capacitor voltage will 0, but when the time pass by, the voltage of capacitor will rise until it reach voltage of the battery and it completely charged. The voltage across the resistor at the beginning will be voltage of the battery 12 volt and it start to decreases to 0 because current start to drop. Okay, this is the mechanism of charging. Okay, how much charge stored in the capacitor? We use Q, C equals to Q over V to calculate the charge. Okay, any questions so far? This is the introduction today. So what you learned today? Yeah. So you learn about what is capacitor and capacitance. You learn about C equals to Q over V. You learn about the symbol, and you learn about how charging discharging happens. Okay. Then we talk about this question just now. Okay. Okay. So that's all. So next class, we will continue talking about capacitor connected in series and parallel. Okay, like resistor, resistor in series, resistors in parallel. Same thing would happen for capacitor. Okay, series parallel connection. Okay, so any questions? Okay, no questions, Yes, if you have any questions, you can WhatsApp me if you want. Okay. Okay, so we stop here. Thanks.